In this video, will I be showing you how you can make a 3D printed Mecanum Rover. This is, in my opinion, a really cool project that involves all the cool stuff you can do, such as 3D printing, CAD drawing, Arduino programming, and some electronic soldering. So what even is a Mecanum Rover? Well, it gets its name from the very special wheels. They are called Mecanum wheels, and the special thing about them is that they have rollers all around, and these rollers are able to basically roll freely as the vehicle is moving. In most cases, this is nothing special. The vehicle is going to behave as any other vehicle that has tank steering. But in one special circumstance, the vehicle is going to travel sideways. How does that work? Well, here's the quick explanation. Let's take a look at this rover that has the red arrow pointing forwards. So in order to go forwards, we need all wheels to travel in the same direction, as shown by the green arrows. In order to rotate, we need the left pair of wheels to rotate in the same direction, and the right pair of wheels to rotate in the opposite direction. This way the vehicle is going to rotate around its center axis. In order to move side to side, as you can see, the left pair of wheels are going to rotate inwards towards each other, and the right pair of wheels are going to move away from each other. Because of the rollers, this is going to create a side to side movement of the vehicle. The project starts in Fusion 360, where I drew the Mecanum Rover. I basically just looked at some pictures of other people who had built these kinds of rovers and then made something that looked kinda like it. As you can see, I have drawn all the details. I've drawn in the N20 motors, and that way I knew when I were to put everything together, everything was going to fit. One thing I forgot to do, and that would have been a great idea in this case, was to also draw in the ESCs, the receiver, the battery, and the Arduino, basically all the electronics components and the wires, because they were taking up a lot of space. But this is basically the model, and it's ready to be 3D printed. One thing to note is that I've made the model parametric. This means that I will be able to change any of these parameters, and then it's gonna automatically update on the model. So let's say I want to change the chassis width. I can change that to, let's say, 150 millimeters. And there we go, it's automatically gonna update it on the model. What I basically do from here is go up to Tools and then Make, and then I can choose whichever part I want to open up in Cura. So now Fusion has opened up the model inside of Cura. Now it's just a matter of setting up your print settings and preparing it for printing. There's of course going to be some parts that needs support, like this piece, because the motor mounts are hanging out. On my rover I used PLA for most of the components. I used PLA for all the orange and black components. The white rollers, they were printed in a TPU material, which makes them a little bit soft. It can be pretty tricky to print in TPU, so I guess you could use PLA instead. Another thing to note is that these axles, this is 2mm steel rod, and the large axles, which sit in here, this is 3mm steel axle. The entire rover is assembled using M3 nuts. They are called M3x6. 8 grub screws are also used to connect the motor to the axle. The files for this project will be on Thingiverse. To make this rover work, it requires about 150 lines of code. It's actually pretty simple. Here is a quick explanation of what it does. The overall goal of the code is to translate the stick movements on the transmitter to 4 motor speeds on the rover. So when we move the sticks on the transmitter in a certain way, the code is gonna translate and combine those sticks movements into the 4 motor speeds such that the machine or the Mecanum Rover is gonna move the way we want it to. Looking at the diagram, you can see the radio transmitter is sending a 2.4 GHz signal to the radio receiver. The radio receiver is then sending a ppm signal to the Arduino, which is doing some processing to basically combine the stick movements on the transmitter, and the Arduino is then making 4 PWM signals to drive the 4 motors. A ppm signal is actually pretty simple. It's just a pulse train of 0 and 5 volts that then is read by the Arduino. By measuring the time between each pulse on a rising edge, we can determine the value of each channel. So to be more specific, the channel values consists of the elevator channel, rudder channel and aileron channel. Each of these channels correspond to 3 different behaviors of the rover, as explained in the beginning. The elevator is forward and reverse, the rudder is rotation around its center axis, and the aileron channel is the side-to-side movement. The channel value is basically being multiplied by the channel mask, and then all the values are summed together into the 4 motor speed values. In some circumstances, the motor values can be above or below 100 or minus 100. Therefore, I'm scaling all the values to fit within that interval. After that, the values are sent to the motor controllers. Wiring the electronics is pretty simple. You just need to connect everything according to the schematic. To quickly explain what everything is, the BEC is a battery elimination circuit that will provide 5 volts. That is used to power the Arduino when it's not connected to the computer. Usually ESCs have a built-in BEC that you can use. The receiver needs to be a ppm receiver. That's where all the channels are sent through one single wire. It's usually marked on the receiver if it does ppm. S-bus won't work. As you can see, the 4 ESCs are connected to pin 3, 9, 10 and 11. In my case, I used 2 dual ESCs instead of 4 single ESCs, but it's the same in the end. I didn't draw in any of the power electronics on this schematic, so you need to power all the components as you usually would. I decided to solder the wires to the Arduino because if I use the small connectors, the Arduino wouldn't fit inside the vehicle. Okay, I think I finally got everything crammed together enough so that I can put on the lid. Let's see. I obviously didn't account for all the wires in the CAD model. That's such a rookie mistake. But I think it's gonna be alright anyways. There we go. As you can see, it's done and it's working. Okay, let's see. So the controls are like this. So forwards and backwards, and then this is like the throttle does nothing, but this is gonna yaw, and then this is side to side. All the files, all the code, and a complete materials list will be uploaded to my Thingiverse page, so you can download everything with some added instructions for how to make the rover. If you liked the video, then please make sure to subscribe to my channel, because I will be making more videos like this in the future.